Hello, so today we're going to be taking a look at a program called STEP. It's a physics simulation program. So there it is, it's called STEP. But before we take a look at that, let us look at how to install the program. So to install it, you need to go to the Ubuntu Software Center and then just search for STEP and it should be there. Yeah, so let's search for STEP. And there it is. Just click install. Install will be right there, and it'll install. So exactly the screen you will see after installing STEP. What I prefer to do is put the undo history over here, because that just makes it a lot easier to navigate the program. Okay, so let's begin with the actual program. So here is a particle. You can place the particle by just clicking on the screen. To move the particle, you don't click the square in the middle. You click the outer areas and then you move it. If you click the square in the middle and drag, you can actually set the velocity of the particle, so how fast it's moving. As you can see, that button is how you run the simulation, obviously. You can zoom in and zoom out. You can add other things, so let's just go through this. You can add a charged particle, a disk. Now a disk will have, so here, that's the velocity of the disk, so which direction it'll go. That's the spin of the disk, and this one, you can actually spin the disk. So I'll show you that when I do a polygon, because it's much better that way. So that's just a box. So if I put in a box, then you can see this is the velocity of the box. Now here's this one. This one will actually rotate the box. And it's the same with the disk, obviously, and this one is the rotational velocity of the box. So you can see that it's moving and rotating. Okay, so that's the polygon. You can pretty much draw a polygon there. Spring, so there's a lot of stuff here you can have a explore. Now the gravitational force I'm not quite sure about, but the weight force works, and that's the one we're going to be using in this video. Okay, so a particle, what I've noticed is with a particle is that if it collides with another particle, it doesn't, so it just moves through. I'll just show you that quickly. Yep, so let's simulate, and that just moves through one another. Okay, it doesn't actually collide. Soft bodies, so those things are these things. You can customize the soft body, and here's a soft body. Oh god, what did I do? Okay, let's start a new one, then enter a soft body. So with a soft body, if I just simulate it, then you'll be able to understand what it is. But before I do, let's get a disk in here. Okay, so and when this touches it, you can see how it moves. So that's a soft body. It's quite cool. Changing the values of these things, so like the velocity or the position of this thing, you can do that here. So in the properties section, you change all the values. You can't change the ones which are in gray, but you can change the rest. So let's just say I wanted it to be a 0.5 kilogram mass. It should move faster. No, not really, because that's a velocity. If it was acceleration, then it would move faster. But anyway, so you can change everything here, and yeah. Okay, and we've covered everything else. Alright, so let's move on to the actual demonstrations. Whoops, that's snapshots. Okay, so let's move on to the actual demonstrations. Let's open a new one. Okay, so for the first demonstration, I just wanted to show you an object crashing into another object. So here's two objects. They both have the same mass, as you can see. It doesn't really matter about the actual size of the objects. They still have the same mass, so they should transfer the same amount of kinetic. Well, they'll always transfer the same amount of kinetic energy. But anyway, let's crash one object into another. So that one is stationary. That one's moving towards that object. This one has 0.5202 joules of energy, This one is 0. If we click simulate, that one now has 0.5 joules of energy, kinetic energy. So yeah, you can see that the object's transferred energy. For the next simulation, we can actually do a box. We can actually drop objects. So this here, I just wanted to simulate gravity. Let me grab an anchor so this thing doesn't move, and put 2 pins here. Okay, so let's begin with the actual putting in the actual objects. This will be object 1. This will be object 2. I'll try and line them up as much as possible. For this one, I'll actually introduce a graph. So here's a graph. So I'll introduce a graph here, and what I'll do is I'll make this graph a little bit smaller. Okay, so what you can do is you can right-click the graph and click configure. So for the x-axis, yep. No, for the y-axis. Sorry. For the y-axis, we can use box 2. It's position. Yep. And I think it's position 1. These should be properly labeled, I think, but and this one's going to be time. So for time, you can click world 1, and then you have time, and that's the only thing. So yeah, let's give that a go, and then let's put another graph for the other one. Okay, so let's begin simulation. Actually, wait, before we begin, I was forgetting to add the weight force. So this is the weight force. The weight force, actually, I won't add that much because, as you can see, it's going off the screen, literally. So let's add 1. Let's put that as 1. Meters per second. That way it'll be quick. Sorry, it won't be as much, as you can see. That one I'll put as 0.5 kilograms. Okay, and I'll click simulate. And as you can see, they both turned around at the same time. Okay, now it's kind of going out of control. But yeah, so that's the other simulation that I wanted to show you. Okay, so now let's just go through some of the examples. So they've given us some examples over here. If you go into File and then Examples, you can open an example. So here I've seen a couple of them, and I like pretty much all of the ones I've seen. So let's have a look at Brownian Motion. This one I like quite. I thought it was quite neat. So let's simulate. Now what's going to happen is it's going to be very, very slow. So this is a feature of the program. You can actually click on this arrow right here, and you can change the run speed. So before I do that though, you can see that the pointer here is changing as the disk. So the position of the disk is changing, the pointer over here is changing as well. So let's change the speed of this, and as you can see, it's quite random. And yeah, so let's take a look at the background stuff. So if I configure the graph, you'll be able to see that it's taking the position. Okay, so that was the position 0 is the x, or the x position of this thing, and position 1 is the y position. Okay, so that is the configuration. So it's taking the x and y position of disk 1. Let us look at another example. So it was quite nice, that one. The 8 pendulum. So this one's actually Newton's cradle kind of thing. So if I click simulate, then you can see that it's basically Newton's cradle. Yep, so that's another one. Look, wave 1. I think this is the right one. Now for some reason there's a bug in the program and this thing is not showing right, but what it says is basically when you start the simulation, the wave starts to travel from the red particle. So here's the red particle, and it starts to travel from the red particle. The blue particle will reflect the wave, and it will travel in a reverse direction until the red particle reflects it again. After some time, the wave will vanish. Okay. So on this one says the graph shows the oscillation of the green particle. Okay, so this particle, the oscillation of it, will be shown on the graph. And as it goes on, it'll pretty much get dampened. So let's just delete these text boxes. But it'll get dampened. The wave will get dampened. And you'll see that. So here, so
we just started. So that's the first wave. Okay, second.
Let's speed this process up a little bit. As you can see, they get more and more curved at the top, and now they're finally a wave. And you can also see the dampening effect now, because the waves are getting smaller. The period of the wave is getting smaller. Okay, cool. So let's actually take a look at the configuration here. So you've got the time on one axis, on the x-axis. On the y-axis you have the position of the particle in the x direction. So remember, the x direction is this way. So that's 0 is the x direction, and you've got the position of that particle. So the green particle. Okay, that's cool. And I think we have time for one more. So we'll go ahead and let's have a look at the two double pendulum. Yep, there we go. So this is just a quick simulation of double pendulum. So I don't like these notes, they're glitchy, but there we go. There's a double pendulum right there. Behind it is pretty much, this is a stick, this is another stick, and then there's two particles. So yep, and that's pretty much it. And there's also a wave force like we had before. So yeah, that's pretty much it. Thanks for watching, guys. And yeah, don't forget to support the developer and download the program if you really like it. Thank you.